Hello friends, in today's question, as shown in figure, blocks of masses m by 2, m and m by 2 are connected through a light string. As shown, pulleys are light and smooth. Friction is only between block C and floor. System is released from rest. We have three things to be calculated. First is find the acceleration of block B. Regarding the acceleration of A and C, what can we say? Find the tension in the string. So there are three blocks A, B and C. The mass of A and C is m by 2, and the block B has a mass of m, and the friction is only between block C and the inclined plane, and the coefficient of friction mu, it is given as tan theta divided by 2, okay, and this is also m divided by 2. So first is, what is the acceleration of block B? Let us start with part A. We ask for what will be the accelerations, and let us draw for that the free body diagram for block B. So this is block B of mass m, and let us put the tension T here, and this side also, and here also. As there is a single string, so tension will be T everywhere. Okay. Secondly, there will be mg in the downward direction, and the angle of is given as theta. This mg can be divided into two components. This angle will be theta, so we are going to have mg cos of theta, and this will be mg sine of theta. And suppose that it is moving with the acceleration of AB down the inclined plane. So we can write the equation for this. So we can say that in the downward direction we have tension here is 1 and here is 1, and then there's mg sine of theta. Okay, so we can say that mg sine of theta plus t, and in upward direction we have two tensions, say minus t, and we assume that this acceleration is AB, so m into AB. So these tensions cancels out, and we also get that mass cancels out, so we get acceleration of block B is equal to g sine of theta. So we can say this is the acceleration of block B. Next, let us do the part B, and in this case we are supposed to find out what we can say about the acceleration of A and C, and let us draw the constraint relationship between the two accelerations. Okay, so we have mass A and mass C. They are connected with the help of string, like this. Tension T, and here also there is a string and tension T, and we say block A moves with the acceleration of A, and block C moves with the acceleration of AC. and they will be connected like this. So for the constraint relationship, between block A and C, we have tension T and acceleration both are opposite direction for block A. So we can say this will be minus of acceleration of A multiplied by T, and for C the tension and acceleration both are in the same direction, so this will be plus T AC is equal to 0. From here we can say that acceleration of A is equal to acceleration of C, and you can see that acceleration of block A is equal to acceleration of block C, and we assume that let it be A. You can say acceleration of A, C, and is equal to A. It will be easier to calculate then. Now let us find out what will be their acceleration. Okay. So we can say that for block A, let us draw its free body diagram. So we have this block A, and there will be a tension T in the upward direction, and here it will be MAG. This angle is given as theta, so we can divide into two components. This will be theta, and we get MAG cos of theta, and this will be MAG sine of theta. So therefore, and it is traveling in the downward direction with the acceleration A. So we write the equation as MAG sine of theta minus T will be equal to MAA. Let us call this equation number 1. And for block C, this is theta, and this is block C. Now the friction exists between block C and the inclined plane. Okay. So we are going to have this will be our MCG divided into two components. This will be theta, and this will be our MCG cos of theta, and this will be our MCG sine of theta, and it is moving in downward direction with the acceleration A. So we are going to have a friction FR, and there is tension T also in the downward direction, and let us suppose that normal is given as NC. So from here we can say that our FR will be equal to mu into NC. Value of mu is given as tangent of theta divided by 2, and NC is our MCG cos of theta, so we can say that FR will be tangent of theta divided by 2 multiplied by MCG cos of theta. You can solve it further also. This will be sine oblique cos, cos cancels out. So we get FR is equal to, this will be sine of theta divided by 2 multiplied by mcg. This will be cos of theta and divided by cos of theta. Cos and cos cancels out. So we get friction Fr is equal to sine theta mcg divided by 2. So this is the value of the friction. Now we can write the equation as traveling in downward direction. So that will be T plus mcg sine of theta, and we have Fr is equal to mc multiplied by acceleration A. We substitute the value of Fr. Okay, let us solve it first of all. This is second equation. So adding 1 and 2, adding 1 and 2, t and t cancels out, so we get this as mag sine of theta plus mcg sine of theta minus Fr is equal to A is common, so this will be ma plus mc. Now we substitute value of ma. Mass of A is given as m by 2, this will be g sine of theta. Mass of C is also given as m by 2, g sine of theta minus, this will be our sine theta m by 4 multiplied by g is equal to, this will be A m by 2 plus m by 2. Now this m cancels out throughout, so we get g sine theta plus g sine of theta. So, and this is also g sine of theta, we take it as common, so you can say g sine of theta, this will be 1 plus 1 minus 1 by 4 is equal to A, and we get the acceleration A will be equal to, this will be 8, and the LCM will be 4, so this will be 8 minus 1, and we get this as, I think, so this will be our 1 by 2 and 1 by 2, and so we get acceleration A is equal to g sine of theta, this will be 1 minus 1 by 4, which will equal g sine of theta 4 minus 1 divided by 4. So we can say from here that our acceleration is equal to 3 by 4 g sine of theta. We can say that from here, as the acceleration of block A and block C is same, okay, this is the acceleration of block A and block C. And next we are going to find out a tension. So let us consider equation 1. So you can see from equation 1, which is given as mag sine of theta minus t is equal to MAA. Capital A, sorry. Yeah. From here we can say that tension T will be equal to, taking MA as common, this will be our G minus A, and MA is given by M by 2. This will be G minus acceleration given as sorry, I missed it. This is G sine of theta. So we get T is equal to G sine of theta minus of A. So from here we write T is equal to, it is given as M by 2 G sine of theta minus 3 by 4 G sine of theta, and you can say this will be equal to M by 8 G sine of theta. Okay, so you can say the tension T is equal to M by 8 G sine of theta. So this is the tension in the string. So this completes all the 3 parts. Thank you.